Hello everybody. I just wanted to post a video here on some example problems from 1.7. We'll start with one that most of you saw in class, the maximum value problem. So a square of side x inches is cut out of each side of each corner of an 8 by 15 inch piece of cardboard, and the sides are folded up to form an open top box. Your first task is to write the volume as a function of x. So the first thing that you would do in this problem is you would draw a diagram. So your diagram doesn't have to be real elaborate. It says it's an 8 by 15 piece of cardboard, so that just tells you the length you're starting out with is 8, and the other length and the width you're starting out with is 15, or vice versa. And then all you're doing is cutting out a square from each corner. So once you cut out those squares, well, how big are the squares? They're x by x. And what you've just done is you've cut out the corners of this piece of cardboard so that you can now fold up those flaps and create a box. Well, your task is to find the volume of this box. Hopefully you remember your volume formula. It's just going to be length times width times height. But we want that in terms of x. So the width of the box previously was 8 inches. Well, if you cut out x by x from each corner, so take x away and take x away, your width then becomes 8 minus 2x. Do the same thing for your length, and your length becomes 15 minus 2x. And then how big is that flap, or how tall is that flap going to be that folds up? Well, it's going to be x. So that's your volume function. Now the next question I have is, what's the domain of this on this volume in terms of x? That might be written in this way: find the domain of v as a function of x. Means the same thing. So think about it. Your domain is what you can plug in for x. Well, you're gonna cut out a corner, or you're gonna cut out all the corners. So you have to cut out something. So it's not going to be a negative number. It's not going to be 0. So your domain is going to go from just past 0, so I use a parenthesis, until what? Well, if you look at the shorter side, it's 8. If I'm cutting away from both sides, if I'm cutting this direction and this direction, what's the most that I could cut out of this box, or of this side of the box? Eventually, I would hope you'd realize, well, if you cut 4 from each side, you'd cut the entire flap off, and then you wouldn't be able to fold up any sides. So you've got to cut off less than 4. That would be the domain on this function. The next question that I have is to graph the volume function as a function of x over the domain that we found. That means look at the x values from 0 to 4 and use the maximum finder on your grapher to determine the maximum volume such a box can hold. So that's what we're going to do. We're going to graph that function. So you go under your y equals, and you can graph it just like that. You don't have to multiply it out. 8 minus 2x, 15 minus 2x times x. I'm going to go to my window right away, and I just want to look at from 0 to 4, since that's the domain that I'm using, or that's possible for me. And then for my y min, well, the volume's not going to be less than 0, and I don't know maybe right away at first how high I need to go on the graph, but after a few tries you'll probably figure out a nice window. Wow, that's a nice looking graph. So now the question, if you recall, is use the maximum finder on your grapher to determine the maximum volume such a box can hold. Well, the maximum finder, if you go second, calc, number 4 is maximum. Enter a left bound, so something to the left of the maximum, like 0. Something to the right, like 4. And then this is the fun part, you get to guess. Well, it looks like it's not quite halfway, but more where the maximum is. I'm looking right up here. This maximum is going to be, I don't know, maybe 1.6. Whoa, that was a good guess. Looks like it's 5/3 or 1 2/3. So why did we do this? Well, what do these numbers represent? This y right here, that's the same as the v in our equation. Y is the volume, so that's the maximum volume. The maximum volume that we could have gotten was 90.74 approximately cubic inches. How big would the block be, or how long would x have to be to get that maximum? Well, that's the x value on your graph. That's that 5/3. So x equaling 5/3 would give us the maximum volume. That's a fun problem. The next problem I want to show you involves using the data table on your calculator in a stat plot. So if we're constructing a function from data, you're going to be given a set of data points of the form xy to construct a formula that approximates y as a function of x. So you need to make a scatter plot of the data points. Keep in mind they don't need to pass a vertical line test. You need to determine the shape of the plot, whether the points seem to follow the graph of a familiar type of function, like a line, a parabola, a cubic, a sine curve, etc. And then you need to transform a basic function of that type to fit the points as closely as possible. That's what we're going to do here. So what you need to do right now is, in your calculators, you need to look at this chart of data here, and what you can do is, you don't need to type in these years as is, but you can start at just 0, 1, 2, 3, etc. for x, and then for y, you would put in these numbers as written. So that's what I'm going to do right now. Just going to clear this out because I don't need that equation in there. Remember that you go to Stat, Edit, so Enter, and then type in that data. once you've typed in all that data, you can then go to second, stat plot, enter, and then this is where you can turn that plot on, and pressing enter right away turns it on. You can verify it's going to be a scatter plot here. You're using list 1 for X, list 2 for Y, um, and so on. So that all looks good. Then what I do before I even graph, I just do zoom stat. That's number 9, I believe. We'll just verify that. Yep, number 9, so you can press 9, and there's my data. So the next thing that we're going to do is we're going to take a look and see what kind of an equation is going to match that data the best. So what we're going to look at is we're going to look between, and you can ignore these equations. These equations are not what you're looking to use. We're going to use the quadratic regression and the linear regression to see which model fits the data the best. So how do we do that? You're going to go to stat, go over to calculate, and then you're going to do number 4, and then you're going to do number 5. Number 4 is a linear regression line, and number 5 is a quadratic regression line. So if I do 4 first, I get all of this data. This is telling me that the A value would be 19.3, the B value would be 176.9. This R squared is what we're interested in. The closer that is to 1, the closer that the data relates to the actual function that we're talking about. So what I'm going to do is I'm just going to take a little picture of this so I don't have to copy it down. You would just write that down to compare. So we have that information. That's for the linear regression. Now what we're going to do is we're going to do the same thing, only look at the quadratic regression. Press enter. And now I have this data to compare. So again, I'm going to just take a screen capture so it's a little easier to compare. And when I put that information side by side, again, the A represents what goes in for the A right there, the B here, and the C there. This R squared is what we're comparing. You can see that the R squared is higher or closer to 1 on the quadratic regression than it is on the linear regression line. So what that means is the quadratic regression line fits the data more closely than the linear one. So that's the model that we would use. I should point out, if for some reason you're not getting those R values, not a big deal. All you'd need to do to turn those on is go to your catalog, so second, 0, that's catalog. And then right away up here you can see that it's got an alpha character. That means you can press a button and it'll go down to that letter at the beginning of that letter in the catalog. Well, what you want to do is you want to turn diagnostic on. So I'm going to press the D to jump down to the D's. And it looks like I passed it. And you would just press enter there. I don't want to turn it off. You wanted to do diagnostic on, and then you just press enter. You would go back and do the same thing we just did. And you would have your R value show up at that point. Or your R squared value, excuse me. So why did we do all that? We did that to write the equation that best fits that data. So what would our equation be? Well, we would take this information and we would have the equation 0.8 x squared plus 11.2727x plus 188 1.94. That would be the equation that best fits the data. The last thing I want to mention is that there's a nice chart in your book that you should study and take a look at that goes through all the different functions and mentions where we'll be talking about them. So you'll want to jot down this information into your notes. And again, it is in your textbook.